Hello everyone, today I will continue my Scramjet series, and again I have planned to make this a very short video, but it will probably get longer than planned anyways, so I'll again only be talking about one very small part of the thematic, and that is why scramjets are not yet commonly used for space launches, and won't be commonly used for space launches in the near future either. They probably will be in the mid or far future, although other technologies might also come a long way until then. Now, there are a whole lot of reasons. Space flight and launch system design are really complicated, but to the most basic, they aren't advanced enough yet. They actually are just experimental, and at this point they aren't advanced enough to use them at all anyways. But in the state they are currently being developed in, they wouldn't be quite worth it either, because they wouldn't cut launch costs that much. They would cut the lift off weight by a good bit less than 50% probably. They won't give you that much delta V. They need a certain speed to run at, that so you need some form of rocket engine probably to speed them up in the first place, and then they can, at least in the way they are currently being designed and developed, only run up to a certain speed too, so they can only bring you through the lower part of the atmosphere or upper part of the atmosphere, but they can only bring you that high, and they can only give you that much speed too. So they'll probably save you something like 2000 meters per second of delta V, given that scramjets are currently designed to run at Mach 6, and you will probably have a range of something like Mach 4 to Mach 8 that they actually run at, and then you can also gain a little bit of altitude with them, but that's not that much. That is, with the specific impulse of current rocket engine designs, it already only cuts your lift of weight by about 50% to save this, but then the scramjet itself also has a mass and also needs fuel, and it also makes the launcher design much more complicated. Nowadays, rocket design, you can usually get to space with 2 stages or 2.5 stages. Hypothetically, with the technology currently being developed, rocket SSTO would actually be in the hypothetically possible realm that is with the Raptor engine of SpaceX, and which has a really good thrust weight ratio, by far the best thrust weight ratio of any rocket engine designed for actual space flight ever, and combined with modern carbon fiber fuel tanks, which are currently kind of in development, and the Raptor engine 2 is not yet being actually flown, but just ground tested for short terms. But that actually would bring a rocket SSTO into the possible realm, with though the practicality is still kind of questionable. So a scramjet would require at least 3 stages, at the very least 3 stages to work. You would need something to get the scramjet up to speed, unless it's some super futuristic hybrid scramjet design that we don't really have yet, that can get itself up to speed, which is actually kind of possible if you're talking about a small airplane. Then you could make a sort of scramjet turbojet hybrid that kind of transforms itself and could get itself up to speed, but on the scale of a space launcher, this is not really possible. So you'd need a rocket engine to bring it up to speed that might keep running in parallel with the scramjet or be jettisoned when the scramjet starts. But either way, that gives you two stages with a scramjet, and then since the scramjet won't be carrying you all the way up to space, you'll at least need some rocket engine to actually deliver you to space. So you'll already need a three-stage system, possibly a four-stage system, since even from the scramjet cutoff point, it's still quite a bit of a way into space, and doing that single stage is, of course, also possible, but still kind of impractical. And the scramjets themselves, of course, are still in development. They're still being tested, being designed in the first place. Then they're not really that reliable at this point, and they're not simple enough either. Space launchers are actually designed to be kept as simple as possible. They still get really complicated, but since spaceflight is just very complicated, you really have to try to keep a space launcher as simple as possible to keep it manageable and humanly possible to build at all. And they would also require to completely rethink the whole ascent path of how a rocket launch works. You would have to start a gravity turn, or probably not even a gravity turn, a turn into an almost horizontal attitude almost immediately, then reach speed, then ignite the scramjet, follow the line of continuous dynamic pressure or constant dynamic pressure, and then gain vertical speed again after you've reached some horizontal speed, and then get into orbit, which is something many Kerbal players are already used to when building air-breathing SSTOs, but Kerbal does make things a lot simpler than they are, and really, most real-life space launchers just stick to a plain gravity turn for very good reasons. And that sets the bar pretty high for scramjets to actually be used. They would have to reach a thrust-weight ratio and a reliability at or beyond that of current rocket engine designs, or they would have to be able to operate at much higher speeds, which is probably even easier to reach since they just are more complicated than rocket engines, but with modern material developments it might actually be possible to ramp them up to a lot higher speed than Mach 6, so you might be able to gain a little more delta V from them. And their specific impulse is of course way better than that of a rocket engine. In fact, the fuel a scramjet needs would be almost ignorable compared to the amount of fuel a rocket engine would need for the same task. So you could really just say you basically save the fuel that you would need for the task the scramjet can do for you. So until scramjets improve a lot, they're currently quite impractical for actual space launches because they seem really fast and powerful for aviation standards, but really for spaceflight standards, you kind of have to start thinking in several kilometer per second ranges, and in that kind of range, the scramjet is really just at the very beginning of mattering at all, as their top speed is at about 2 kilometers per second at this point. But of course, scramjets are currently being developed in the first place. They are still a future technology, so really it's no surprise that they are currently really impractical, and it does seem inevitable that they will improve in the future. So I hope this was kind of interesting, and thanks for watching.